Hello friends, welcome to Learner's Planet. Friends, this is our first session for polynomials, and in this session we'll be discussing algebraic expression, identities, factorization, remainder theorems, factor theorems, and more. Okay, uh, before we move further, let's have a quick recap of some basic algebraic terminologies. You might have studied in your previous years the term constant. Now, what's a constant? Constant is a symbol having a fixed numerical value. Okay, that means the value of a particular quantity is fixed, then it is known as constant. Suppose number 2. Universally, number 2 is 2 only, nothing else can be assigned to it. So it's a constant. And now what is variable? A symbol which takes various numerical values is called a variable. Suppose I have a number x. Now x can be 2, 3, 4, 5. It can be any negative number, that is -1, -2, or it can be any fractions, say 2 by 3, 4 by 5. So we can assign different values to x. So it's a variable. So I hope you are clear with the difference of constant and variable. Now let's recap the term algebraic expression. Now, what is an algebraic expression? It's a combination of constants and variables which are connected by the signs of fundamental operations, that is addition, subtraction, multiplication and division. Okay, so we call it a algebraic expression. Let's see some examples of algebraic expressions. Here we see 3x square plus 4y plus 2. So this is an algebraic expression. Similarly, minus 5x cube plus 3x square plus 4x plus 2. It's an algebraic expression. Okay, it's a combination of variables as well as constants. Okay, and they are connected by mathematical operators like addition, subtraction, multiplication, and division. Okay, now here we see. In this expression, this 3x square, 4y and 2. These are the terms of this algebraic expression. Similarly, over here, 5x cube, 3x square, 4x and 2. These are terms of this algebraic expression. That means it is a complete algebraic expression and these are the terms of this algebraic expression. Okay, now one more term over here is a coefficient. Now what is a coefficient? Here we see 3x square. Here 3 is a constant and x is a variable. Now coefficient is what? Here suppose we whatever is being multiplied to that particular variable. So here 3 is multiplied to x square, that means 3 is the coefficient of x square. Okay. Similarly, coefficient of y is 4 and 2 is the constant term. Just see over here. The coefficient of x cube is -5, coefficient of x square is 3, coefficient of x is 4 and 2 is the constant term. Okay. So I hope you are clear with the basic terminologies of algebraic expressions, and definitely you have already done these terminologies in your previous classes. So now let's begin with the next. What's a polynomial? Now a polynomial is an algebraic expression in which the variables have non-negative integral exponents. Okay. Here we see the example of polynomial, that is 3x square plus 4y plus 2. Here variable is carrying a positive power, isn't it? X is carrying square. Similarly, y is having power as 1 and 2 is having power, here the variable is having the power as 0. Okay, so the variable should have the powers as non-negative integral values. Okay, so it's maybe 0, 1, 2, 3 to any number. Okay, similarly over here It's minus 5x cube. X is having power s3. Here x is having power s2. Here x is having power s1. And here x is having power s0. Or we can say exponent is 0. So these are the examples of polynomials. Suppose I have an expression x raised to minus 3 plus 5x square minus 3y plus 1 by 2. Friends, we cannot say this expression as a polynomial because in this case x is having the power as minus 3. But in case of polynomials, the variable should carry the power as positive, or we can say non-negative integral values. Okay, so let's have one more example. See, x cube plus x square minus y plus 3 by 2. Just see whether this is a polynomial or not. Yes, it is a polynomial because in this case all the variables are having non-negative integral exponents. Doesn't matter if a constant is a fraction. Okay, it can be a fraction or it can be an irrational number also. Okay, so basically variable should be having non-negative integral exponents. Okay, I hope you are clear. Now, let's see the polynomials in different variables. A polynomial that contains only one variable is known as polynomial in one variable. Here we see this is a constant part, and here we see just one variable, that is x. Okay, so this sort of polynomials are known as polynomials in one variables. Okay, in this case x and y, two types of variables are there, so we call them polynomials in two variables. Okay, similarly in this case, here x, y and z, three variables. So we call it polynomial in three variables. Okay, so here there are two terms, here there are two terms, here there are three terms. But it is the polynomial in one variable since only one variable x is there. Here there are two variables x and y. Here there are three variables x, y and z. Okay. Now we see degree of a polynomial. The highest exponent of the variable in a polynomial is called the degree of the polynomial. Suppose we have a polynomial like x raised to 5 plus 3x square plus x raised to 4 minus 7x square plus 5. Then what is the highest power of any variable? That is number 5. So it is a fifth degree polynomial. Okay, or we can say suppose it's x cube minus 5x4 plus 7x square raised to 5 plus 10. Then it is a 10th degree polynomial since the highest power which a variable is carrying is 2 into 5, here x raised to 10. Okay, so it's a 10th degree polynomial. Okay, now what is zero polynomial? It is a polynomial of degree 0. That is, we can call it as a constant. See here 3. 3 is written as 3 into x raised to 0, and x raised to 0 is obviously 1. So it's a 0 degree polynomial. Similarly, linear polynomial is what? It is a polynomial of degree 1. Okay, and it is a form of ax plus b, where a and b are real numbers, and they can be any number, any non-zero numbers we can say. Let's take an example. It's 2x plus 3. We can say 5x minus 3, 4x plus 2, 6x minus half. Okay, so all of these are in the form of ax plus b, and these are known as linear polynomials. Why they are known as linear polynomials? Because the variable is carrying the power as 1 or exponent as 1. Here x, x, x. In all these cases, x is having the power as 1. Okay. Now, quadratic polynomial. It's a polynomial of degree 2. It is in the form of ax square plus bx plus c, where a, b, c are non-zero real numbers. Okay, so let's have an example. It's 5x square plus 6x minus 9. Here the variable is having the power as 2, that is x square. So it's known as quadratic polynomial, or we can say it's a second degree polynomial. Okay, more examples we can take. It's a second degree polynomial. Just see over here. Okay. Similarly, cubic polynomial. If it is a 3-degree polynomial, that means if the variable is carrying the power as 3, then it is known as cubical polynomial, or we can say third degree polynomial. The format is ax cube plus bx square plus cx plus d. And here a, b, c, d are non-zero real numbers. Just see over here as an example. It is 4y cube plus 9x. Now what is the power that variable is carrying? The highest power we can say it's y cube. So cubical polynomial is this. Okay. Similarly, more types of polynomials are there. Suppose this is x raised to 7 plus 1. It is a 7th degree polynomial. If it is x raised to 12 minus 5 by 2, it is a 12th degree polynomial. Or if it is x raised to n minus or plus maybe 5x square plus half, then it is an nth degree polynomial. And here n should be any positive number. Okay. If it is less than 2, then it will be a second degree polynomial. If it is 1, then it is a second degree polynomial. If it is greater than 2, then it is nth degree polynomial, that is greater than 2. Okay. So I hope you are clear with the degree of polynomials. Now friends, let's discuss the terms monomials, binomials and trinomials. Now polynomials having only one term is monomial. Here we see x raised to 5, 3y. This is a single term and this is also a single term. Okay, so these are known as monomial. In this case, there are two terms. 3x is a one term and 2 is another term. So it's a combination of two terms. So we call it a binomial. Similarly, here there are three terms. So we call it a trinomial. Okay. X square, 5x and 2, 3 terms are there. Similarly, if n terms are there, we call it a polynomial. Polynomial means n terms. Now n can be 1, 2, 3, any number. Okay, any positive number. Okay. Now let's discuss some of the problems based on polynomials. Let's see the first concept. Which of the following expressions are polynomials in one variable and which are not? Friends, we have already discussed if a polynomial is having a single variable, then it is known to be the polynomial in one variable. Okay, so here we see there is only one variable, that is x. Okay, so it's a polynomial in one variable. Here we see it's a polynomial in one variable once again, since there is only one variable y. Here it's not at all a polynomial because x is having the power as half, that is it is root x over here, and if it is a root x, then it cannot be called as a polynomial. Okay, since the variable should carry the non-negative integral powers. Okay, so it is not a polynomial. Similarly, in this case, x is having the power as -1. Further, we don't want negative integral values as exponents, so even it is not a polynomial. Here in this case, it's a polynomial and there are three terms in this polynomial, and there are x, y, t, three variables are there. Okay, so it's a 3-variable polynomial. So I'm sure, are you clear? I'm sure you are clear. Now let's find out which of the following expressions are polynomials. Now once again, let's have a quick recap. What is the definition of polynomial? Polynomial is an algebraic expressions where the variables are having non-negative integral powers. So let's see this case, first case, it's 1 upon x raised to minus 2. So we can write it as x square. Then it is 1 upon x raised to minus 1. We can write it as x and then plus half. So variables are having non-negative integral powers. So it's a polynomial. Okay. Now in this case, it is x square into x minus 1. Suppose we expand it, it is x cube minus x square. Further, the variables are having positive powers, or we can say non-negative integral exponents. So further, it will also be a polynomial. Okay. Now in this case, here, this is x raised to minus 1 into x minus 1 into x minus 2. Okay. Suppose we expand it, what will be getting? X square minus 3x plus 2 by x. So we will always have an x in denominator. Okay, that means this x is carrying negative power, so it is not a polynomial. Similarly, this case here, this is x plus 1 and there is 1 plus x in the denominator. So we can cancel it and the remaining expression is a polynomial provided x is not equal to minus 1. Okay, so this will be a polynomial only if x is not equal to minus 1. Now students, what would happen if x is equal to minus 1? If x is equal to minus 1, then the denominator will be 0, or we will get a 0 by 0 form which is not defined. Okay, so this expression will be polynomial only if x is not equal to minus 1. So there is a condition. Okay. In various books and guides, these conditions are not given, but you have to keep this condition in your mind. If the denominator becomes 0, then the entire expression becomes undefined. Okay, so it is necessary over here that x should not be minus 1. So let's take the next examples. Here we see the variables are having positive powers, so this is a polynomial. In this case, this x is having positive power, but this x is having negative power. Since we will write it, it's as x square plus x raised to minus 2. So further, it will not be a polynomial. In this case, all the x's are having positive powers, so it's a polynomial. In this case, it's x square x. Okay, and the coefficients are not integers, but variables are carrying integral values or integral powers, so it's a polynomial. So I hope you are clear about the basics of polynomials. Now, in this case, we have to write the coefficient of x square in each polynomial. Okay, now let's see over here. It is 17 minus 2x plus 7x square. Now what is coefficient of x square? It is 7. In this case, the coefficient of x square is not seen over here, so it will be 0. Okay, since there is no term of x square. Okay, in this case, the coefficient of x square is pi by 6. Here we do not see x square, so the coefficient of x square will be 0. In this case, the coefficient of x square is 2. In this case, the coefficient of x square is not 2, but it will be minus 2. Just be very clear about it. Okay, here the coefficient of x square is pi. Here we do not see x square, so coefficient of x square is 0. Okay. Now let's find out the degrees of polynomials. Let's say the first case, it is 7x cubed plus 4x squared minus 3x plus 12. Now what will be the degree of the polynomial? The degree of the polynomial is the power, or we can say the highest power which a variable is having. Here the variable is x and it is having the power as 3, and this is the highest power in this expression. So it is a third degree polynomial. Okay, in this case x is having the power as 3, so it's for the third degree polynomial. Here the variable is y and y is having the power as 1. That means the highest power of any variable in this expression is 1. So it's a first degree polynomial, or we can say it is a linear polynomial. It's over here we assume any variable, suppose it is x, then x is having the power as 0, so it is 0 degree polynomial. Okay, 0 itself is not defined. Okay, we cannot call it as any sort of polynomial. Okay, now in this case the highest power which a variable is having is 6, so it's a sixth degree polynomial. Okay, in this case first of all we have to simplify it, then only we'll be able to get the actual power of variables. So it's x cube over x square plus x4 by x square minus x6 by x square. So it's x plus x square minus x raised to 4. Okay, so in this case the variable is having the highest power as 6, but it is being divided by x square also. So the finally the variables will be having highest power as 4. So it's a fourth degree polynomial. We should be very clear about it. Okay, if there is any variable in the denominator, then simply simplify it, then you should find the highest power of the variable. So it's a fourth degree polynomial. Okay, in this case first of all simplify the expression. It's x cube into x4 plus x cube. So finally it is x raised to 7 plus x cube. So here also you should be clear that the variable is having highest power as 7. So it is a seventh degree polynomial. So in both the cases you should be clear, and first of all you should simplify, then only you will be able to find out the highest degree of the variable. Okay, let's take more examples. Now in this case the variable is x and the highest power which x is having is 4. Okay, so it's a fourth degree polynomial. In this case further it's x raised to 4, so further it is fourth degree polynomial. In this case x is a variable. Here do not get confused, here a will be a constant. Okay, so the highest power which x is having is 4, so it's further fourth degree polynomial. In this case further friends, we have to simplify it, and you will see it is, if x raised to 8 is having highest power, that means x is having highest power as 8, and if you divide it by x square you will be getting x raised to 6. So finally it will be a sixth degree polynomial. Okay, you just divided x raised to 8 by x square, you will be getting x raised to 6. That means 6 is the highest power. So it's a sixth degree polynomial. In this case it's x square, x raised to 7 and x raised to 6, but the entire expression is being multiplied by x. Okay, so here the highest power is 7 and it is multiplied by one more x, that means x raised to 7 plus x raised to x raised to 7 into x raised to 1. So it will be x raised to 7 plus 1, or we can say x raised to 8. So it is the highest power which x is having if we expand this expression. So it's a 8th degree polynomial. So I hope you are clear how to find out the degree of polynomials. Friends, I hope you might have enjoyed the session. In our next session, we'll be doing more concepts and problems related to polynomials. By then, do revise this session, okay?